Hi there, my name is Troy Garner, and I'm the sole developer of the newly released Sharptooth debugger. This video is going to be a brief overview of the features implemented with the tool and some of the ideas and in-development features you're likely to expect in upcoming releases. But first I'd like to talk about the motivation behind this tool and why I use this over the Crestron simple debugger, or even why I started working on my own debugger program when one already exists. And the first point being, I debug my own systems daily to test and make sure that they would operate the way I want them to. And this leads to all kinds of ideas that I have about ways to make this process better and more efficient for my own workflow. And the second one is the fact that Tool Debugger hasn't really been updated in a while, except for some changes in the icons that I've noticed over the time that I've been using it, and there are quite a few features that the new control system, especially 3 series, have implemented, but they're not fully supported by the Crestron Toolbox simple debugger. Some of those being, you can't debug more than one program at once because it would require you to open up more than one instance of Toolbox, which, as many know, doesn't really work that well for most things. It doesn't support Unicode text, whether you're simply viewing that or sending it out. And there's quite a few others that I've noticed in the time that I've been using the Crestron version and as I've been working on developing my own. So we're going to get started here. The first window that you guys are going to see when you open up the Sharptooth debugger will be this About tab. Now, I've already activated my software, so you will see the 29 days up here as the activation period, and my email and serial key are kind of semi-filled out, with the serial key part of it anyways being masked, just for security and privacy purposes. Once you filled out your information there, you'd click the Activate button, and that should store all this information on your computer. From that point forward, you have a period of 30 days in total that you can use this software offline, but before that time expires, you really should work on connecting your PC to internet and then starting this program up, and that will effectively force a check back online to update this interval back to 30 days. So you have another 30 days where you can use this completely offline. There are a few tabs on the left here, so going from top to bottom, the Debugging Tab will be the one that you'll be spending most of your time with this tool. But the Signal tab here represents all of the signals that you've loaded in your debug session from the signal file that you specified in this text box. In here you can view all the signals on a per page basis, with information being their type, the signal number, which doesn't really it's not really important to most people, but in case you need to know that kind of information, it is there since it is provided in the signal file itself, as well as the signal name. From there you can include the module signals as long as you've loaded it by checking this text box before you've hit the debug window button there. I usually keep that unchecked though unless I'm debugging a module, but in most cases I've tested modules thoroughly to the point where I know they're working properly, so I leave this unchecked if I'm debugging my programs because I want to debug the program. I don't want to look at all the information that's flying back and forth between my modules if I know they're already working. But that's what that checkbox will do there. Now, once you've loaded a signal file, all the signals exist in memory, so you can start typing a filter. So this will be the prefix of some signal list that you want to start to pre-populate in this window. And then you can filter that further by specifying a second layer here, which specifies that you only want to load the signal types that are digitals that are prefixed with TP01, for instance. Or you can simply use all if you wanted to. And apply that filter would bring up the list of signals in this window, potentially more than one page if you had a bunch of them. What you can do with that now is you can add it to the watch list, which will bring us to our next tab here. This is kind of like the locals window in Visual Studio, for those of you familiar with it, where you can view signals within a certain scope depending on where the debugger breakpoint has been set. But in this case, the scope is essentially the entire program, so this window will eventually contain any signals that you've added that you want to look at as they change in runtime, and that will be specified by their data column here. From there, you've got the obvious pagination controls. You can filter to group by a certain column. You can do multi-level filtering actually, or grouping. You can even sort by column, or you can search, as I was typing as I was trying to explain the grouping functionality. And if you click the X here, that goes away. You can bring it back up by hitting the Control F shortcut and then start typing, or hit exit to make it go away. This comment column here, this is a little different in respect to the fact that you can add a comment to a runtime signal, so you can say something about it, and then whenever you delete that signal from the watch list or re-add it, it's always going to retain that comment that you've set for it, so you know that you've watched this signal at least one time within the debug session. So going back to the debug tab here, there's a lot of information to cover here, but you're going to start by loading a signal file into this text box, which you can do by clicking the button to the right with the 3 dots. Or you can do as I usually do, and you just drag the signal file over, and it'll pre-populate with the file path for that signal file. This signal file is associated with this small little program here that I've created for this demo, and it really does nothing. It contains all the different signal types that you would ever use in a program, so digital, analog, and serial, just so I can show you the differences between each type as you're using this tool to debug your program. This always on top window is a nice little feature too, so if you have like a text editor open and you want to start typing stuff out, or you have your X panel open and you don't want that to interfere with your ability to view the debugger information, clicking on that to do something, click a button on your X panel or type something in the window here, is not going to put this window behind it as it normally would do if you were to have that option unchecked. So it's a nice little feature. Enable trace message is pretty self-explanatory. And the word wrap and auto scroll, these are control based options. So the auto scroll will enable or disable auto scrolling. So if a lot of information is flying in and you didn't want this thing to keep scrolling because you want to view a certain portion of the debugger information that has already came back, you can uncheck that so that you can read this but still keep the session alive, so that it's monitoring everything, but you can review a certain part of it without having the scrolling functionality be an annoyance with that. So I'm just going to leave that checked for now. Everything in this box pertains to options that are available once you start debugging a system, so I'm going to start that process right here. Here's where you can type in your processor hostname or IP address. There's other connection methods up here, but these are not currently implemented, so if you were to try and use these, you would get the not implemented message box here. But I'm hoping to implement these in some future release, so keep an eye open to expect these to be working at some point. But TCP for the most part is what I use on a daily basis. It's just a nice and convenient way to be able to connect to any control system without having to reconnect wires to each controller manually as if you were to use serial or USB connections. So I'm going to use my hostname here. I know the IP address offhand, I just want to demonstrate that the hostname works as well. This is another tool that I wrote, but it basically is the same as the auto discover. So I've copied that hostname out, which is default because it still contains the MAC address. And we're going to connect using SSH, but you can also connect using CTP or SCTP. Or, for those of you who may not know, you can also connect over Telnet. So you would use this protocol to connect to the Telnet port because it's more of a plain text protocol than SSH is, which is a lot of authentication going on and different things. But SSH authentication, this is where you type in your username and your password. But if you haven't set those, it's going to be default, which is Crestron, and password is blank. So you can see the gray text there. That is the default for this, so you don't have to type in Crestron here. That's redundant. So mine is Crestron and blank still, because this is my test controller. But if we hit OK, you'll see that it's loaded 12 signals from the signal file here in X seconds, fraction of a second. Click OK, it's going to start to try and authenticate using SSH. So that's where the key-based authentication comes in. It shows you the fingerprint, so you can verify whether you want to continue to connect or whether you don't. We want to connect because I know we're connecting to MFC3 that exists upstairs. And the auto sync is what brought these signals back. So that's the digital of 0 from the analog equate, which went high, which set the count serial to the ... through the SIO back here. So count was 0, which sets the ... to the count output. Now to start chaining signals and monitoring things, you can start by typing a signal name down here. It'll bring up a filtered view as auto-completion for the signals that you want to use. Or you can click on the signal name here, which will bring up the signal for that number from the signal file. Digitals, some of them you may not be able to set, so these will turn gray, similar to the way the simple debugger works. If, for example, it's a signal that is the output of a logical symbol, like an OR or an AND, or others. So the count, we don't want to deal with that, but I just want to demonstrate what the differences are between what a digital signal looks like down here and serial signal and an analog signal, which is our count for the analog. You can see the signal label here changes the color based on the signal type, and you've got different options for the signal format. Depending on whether this is a analog signal or a serial signal, you're going to get a different list of formats available that you can set for this signal output, because decimal, hexadecimal, %, those don't really correspond with serial signal attributes. So let's just start with analog. You'll recognize these four from the normal tool that you would use from Toolbox Simple Debugger. There's this one other one that I did add just for convenience purposes called the binary format, and this will allow you to view a analog value in binary format, so the ones and zeros, or set it based on a binary literal, which is useful if you're using some A to D or digital to analog symbols in your program for bit flags or something like that, where you don't want to do the conversions from which digital combinations correspond to a certain analog value. You can just set the digitals essentially as the series of ones and zeros, and then assign that to the analog. And the way that's done is it's suffixed with the letter B. So we're going to set it to 15, which is 4 ones. And you can see it changed there because the default format is still set. We haven't clicked that button to set it to a different format for this signal, 22. So let's set it to 15. We did that using the binary literal. You can do that using the decimal value with just typing the number. You can do that with setting it as the hexadecimal value by using the 0x notation, which set it up to 15 again. Or you can use the assembly notation, which is to suffix the character sequence with the letter H. Same thing. Or there's the percent. So if we were to set percent, that's pretty straightforward. That's going to set it to the maximum 16-bit value for the analogs, 65535. You can set that back to 0, and it's going to set the count high again because it transitioned away into the 0 from our analog equate, and which triggers the ... again. But we can also, if we didn't want to see the decimal notation here, you can select signal 22, or select it by typing in the signal name lookup field. And now we set it to the, actually let's use the binary, just so I can show you what that looked like, because we already knew that the binary value of 15 was 1111. Oh, I didn't press set format. So set the value, you can see the binary representation of this value now. So if we do a hexadecimal, that was the F, so it shows you in the 0x notation with a pad of 4, just because that's a good padding for a 16-bit value that the analogs are capable of representing. And so next I want to talk about the serial signal type. As soon as you select a serial signal and it gets populated in this signal debugging window, you'll see this additional checkbox here marked as Unicode. So this is a feature that's provided within the control systems for, I believe, 3 series, because 2 series didn't support Unicode, which seems to be more of what the Crestron toolbox simple debugger was tailored to, since it doesn't support Unicode at all. But we can mark this as Unicode and send a string as Unicode, which is UTF-16 little endian, or LE, for the acronym, which was adopted by Crestron for all Unicode strings. So if we were to send this, you'd see twice as many bytes here, with the actual characters that you've sent being the least significant bits of each of the 2-byte sequences. If we were to set this away from that and then resend the value, it's going to send it as ASCII, so the normal convention that most of you are used to. But the default format for serials is actually the mixed notation. So anything that can be represented as an ASCII character will be shown as an ASCII character, and anything that can't will be shown up as this hexadecimal notation. Analogs, of course, are defaulted to decimal, but we can change this just like we can change the signal format for analogs. So if we did Unicode, now if I send this and mark it as Unicode, it's going to send the Unicode bytes, so it's going to send 8 bytes, but we're only going to C-test because it's considering the fact that this is this is actually Unicode. So I didn't set it there. You've seen it in the regular ASCII notation for that string. But as you can see, we've got marked as Unicode. I'll just clear this out for now. And I'll send the value of test as Unicode, but it appears to look like it's ASCII because the signal format that we're displaying is Unicode. If you were to send an actual Unicode string here, it would show up as the Unicode text up there, which is really nice. You can also send the actual Unicode string as non-Unicode, but it's going to recognize it as Unicode because it's in a Unicode format. So tests, I believe that's right, we'll see in a little bit here. Yeah, so it came back showing up as normal because we're displaying it as Unicode. If you wanted to see everything in hexadecimal, so say you're dealing with a protocol that doesn't use characters as much as it uses bytes, so maybe a project uses the start of sequence and end of sequence bytes and some other flags that represent values and certain identifiers that map to certain command types, then you would use something like hexadecimal, where you can just view the actual byte sequence or character sequence. Sorry, I didn't set it to hexadecimal there, as the actual byte values in hexadecimal format. So there was an example of Unicode, so it thought I was sending Unicode there, even though I was sending the value of test. It was trying to map these two characters out to a Unicode character from some code page. ASCII, so if you had anything that wasn't ASCII capable, let's make sure we set the format this time. It's just gonna show up as a question mark, I believe, is what I've done, or a dot. So the same thing like a hex editor would display in the text side. For anything that couldn't display as text, it'll show up as a dot. So now we can add these to the watch list. So anything that you type down here, you type in a signal name, you can add it to the watch list. If you didn't type in a signal that existed within the file, so COUN is no signal down here. It's just gonna find all the signals that are prefixed with the text that you've typed in the signal name lookup, and it's gonna add all of these to their watch list, which is kind of a whoops. Maybe I got rid of that feature. But you can do this from the this window too. So add all the signals to the watch, and it's going to add all of them, and then you can group from there. So same thing, just different tab. So you can add it to the watch list doing this to first single signals. And if it already exists, then it won't add it another time. Whoops, that wasn't the watch list. So here you can type in your signal comment. You can actually change the signal format from this view, as long as you know their spelling. It doesn't need to be case sensitive for the signal type, and it will change that automatically right there in that window, which is kind of nice. Because the other thing you can do is you can actually copy this out, and then you can paste it over another one, as long as it's of the same signal that has that signal format available to it. Digitals, it'll show up as the editing view here, but there's no other signal formats other than bool for digitals, because it's basically true or false or 1 or 0. You can delete to remove signals from the watch list. And there's some other filtering options that you will discover at some point, which are kind of useful. Now, the last few checkboxes and buttons in this signal debugging window in the bottom here, these are to do with the debugging mode and whether or not you actually see signal information come back for a specific signal in this debugger output window. And this is actually where the prefix comes into place. So if I was to type in COU, you see a list of signals here that all pertain to that kind of prefix. So it wasn't with the add watch button, but if you were to click signals on or off, because that's not any signal, it's going to apply to all of the signals that are prefixed with these 3 letters. So I can turn all of them off or turn the ignore flag on for all of them. And now if I was to change this, you won't see this change, you won't see that change, because you're not getting that information back from Debugger. You've told it to turn that signal off and or basically ignore the signal. There's also another mode here that Crestron provided, which is not global debug mode. Global debug mode is essentially where you start off debugging all signals at once, and then from that point you can choose to weed out signals that you don't want to see in this window by turning them off or ignoring them. With debug signal or debug mode off for the global flag, you start with basically everything for signals turned off. So I can set signals and it changes them on the control system, but you won't see their information in the debug window because it's not feeding you back that information for the signals that you've turned off, essentially. So we can turn the signals back on, and now if I was to set that, everything that's prefixed with COU will now be debuggable. And it gets a little used to this kind of layout. It's not exactly the same as simple debugger, but I've played around with different ways to represent signal collections and change signals on the fly, and I think this is a pretty convenient way to do it. At some point I was thinking about doing like a unit testing framework where you can assign rules to collections of signals and maybe validate whether those rules are being adhered to, and that's going to take a little bit of work. I may or may not implement that, but I do have a lot of ideas coming up for the future releases of this product, and I'm hoping to develop this into something that is going to be greatly useful to many programmers out there. So I believe that's all for now. If there's any questions, I'm sure I will see them in the support inbox or in any bug reports, or I may discover them myself as well, or if there's any issues or any ideas that I believe should be incorporated into this product. Thank you for your time.